Lesson 6.1, Graphing Systems of Equations. Oh, okay, in this lesson, you will learn to determine the number of solutions a system of linear equations has and solve systems of linear equations by graphing. Vocabulary for this section is the system of equations, consistent, independent, dependent, and inconsistent. So, when you're solving a system of equations, there's different numbers of possible solutions. So there's a chance that there could be only one solution. If there is only one solution, that means that the graph or the solutions are consistent and independent. If there is an infinite number of solutions, that means it's consistent and dependent. And if there is no solution, that means it's inconsistent. So if there's any sort of solution, that makes it consistent. So that's the difference between inconsistent and consistent. Consistent has at least one solution. Inconsistent doesn't. Okay, independent, indie, if you think about the term indie, like individual or whatever, it means one, right? So consistent, independent is just going to have one solution. Okay, and consistent, dependent, that's going to have more than one solution. It's going to have infinite. And yeah. So use the graph to determine whether the system is consistent, inconsistent, and inconsistent, or independent or dependent. Okay, so in order to figure out the number of solutions, the solutions are where the lines touch each other. So if I graph line 1 and line 2, where they touch is going to be my solution. So I'm going to graph this first one first. So it has a y-intercept of b of 1. I start at 1. And then it has a slope of -1. So -1 over 1. So that means it's going to go down 1 and forward 1. So it's going to be like here and here, and it's going to keep following that pattern. Okay, so if I were to connect my dots and draw a line to the best of my ability, because it's hard on this. There we go. Close enough. Right, and if I were to do this one has an intercept of 4 and a slope of 1. So that means that one starts at 4, and it also has a slope of -1. So same thing, it goes down 1 and forward 1 from there. So looking at these two lines that I get, are they ever going to cross each other? Are they ever going to be at the same point anywhere? And the answer is no, because they're parallel. So if you get a pair of parallel lines that are never touch, never cross each other, that means that it is inconsistent. Just inconsistent. Or basically no solution. Okay? So there's okay. For B, use the graph to determine whether the system is consistent or inconsistent, and if it is independent or dependent. So again, I want to graph both of them. So I'm going to graph this first one. So it has an intercept of -3 and then a slope of 1. So that one's going to go like this. And then we have this one. This one has a slope of -1 and an intercept of 1. So it starts at 1 and then has a slope of -1. So it goes down 1, forward 1, like this. So I want to know where or how many solutions this is going to have. It only touches at that one point. So use the graph to determine whether it's consistent or inconsistent. So remember, consistent meant it had a solution. So this one has a solution, so it's consistent. do we have one solution or many solutions? So indi meaning one or many. So we're going to have independent. So this is consistent independent because it gives us exactly one solution. Okay, next one. Graph the system of equations, then determine whether the system has no solution, one solution, or infinitely many solutions. If the system has one solution, name it. So same thing, I want to graph these first. So I'm going to graph this first one, and that one has an intercept of 3 and a slope of 2. So that's 2 over 1, so it goes up 2, forward 1. So that's going to be like this. All right, and if I want to graph my other equation, this one, I want to get y by itself. So to do that, I'm going to subtract 8x from both sides. So I get negative 4y equals negative 8x minus 12, and then I'm dividing everything by negative 4. So when I do that, I get y equals 2x plus 3. So this one, if I were to do this, I have an intercept of 3, and I have a slope of 2x, 2. So this is going to give me the exact same line. So if I get the same line when I graph both of them, that means there's going to be infinitely number of solutions because anywhere where they cross is going to be a solution. So I can draw an infinite number of points on this line to get it. So this is infinitely many solutions. Okay, for this one, graph the system of equations, then determine whether the system has no solution, one solution, or infinitely many solutions. If the system has one solution, name it. Okay, so again, I want to solve these by, I can graph these by using intercepts. So if I put in 0 for x, I'm going to get y equals negative 2. So I can do y equals negative 2. And if I put in 0 for y, I get x equals 4. So I can graph the point x equals 4. And then draw a line through them. Okay, and then if I were to do the other one using intercepts, if I put in 0 for x, that means y is 1. And if I put in 0 for y, x is negative 2. So I'm doing 1 on the y-axis and negative 2 on the x-axis. So if I graph these, I'm getting this line here. And so again, I get parallel lines. So this means that there is no solution because those two are never going to cross. There's no point that falls on both lines. Okay, last one. Naresh rode 20 miles last week and plans to ride 35 miles per week. Diego rode 50 miles last week and plans to ride 25 miles per week. Predict the week in which Naresh and Diego will have ridden the same number of miles. Okay, so the number of miles is going to be equal to the rate times like how many miles per week they're doing times the number of weeks plus the initial amount. We can call it like this. So this is kind of just using y equals mx plus b. So remember, slope is always a rate. So anytime you see per something, that's usually a rate. Okay, and then this is like your initial. So I want to come up with two equations, one for Naresh and one for Diego. So for Naresh, he started out 20 miles. That's his initial distance that he went. And then he plans on riding 35 per week. So the number of miles he goes is going to be equal to 35 times the number of weeks plus 20. For Diego, he started out having rode 50 miles, so his initial amount. And then he's only planning on riding 25 miles per week. Oops, 2 doubles. Okay, so the number of miles total that he's going to do is going to be 25 times the number of weeks plus the 50 that he had already done. So I want to graph both of these and see when they're going to have the same number of miles. So I want to do my miles over here, and I want to do the number of weeks here. So if I graph these, let's see, if I go by 1, 2, 3, 4, 5, 6, and if I do these by, let's say, 5, we'll do 5, 10, 15, 20, 25, 30, 35, 40, 50, 60. Okay, so for this is my intercept. I have 20. So I start at 20 for this one. And then it's like 35 over 1. So it's going to go up 35 and forward 1 from there. So from 20 going up 35 will bring you to 20 plus 35 is 50, and forward 1. So this would be this line, kind of like that. All right, and if I want to do one for Diego, I don't think I did enough space on this graph. He starts at 20, 50, but then he's only going up 25 each week, so from 50, 75 would be like here, and forward 1 would be like that. So his line is going to do this, and then they would end up meeting somewhere like all the way up here, and that's really bad. So I'll redo this problem. But anyway, you get the idea.